It's already gone. Sometime in the spring of 2026, a comet crossed the orbit of Jupiter and began its final exit from our solar system, never to return. We had less than 12 months to study it. 12 months to examine something that had traveled for billions of years just to pass through our cosmic neighborhood. And in those 12 months, we found something inside it that should not exist. Water carrying a chemical fingerprint so alien, so extreme, that it matches nothing ever catalogued in the 4.5 billion year history of our solar system. Not a single comet, not a single asteroid, not Earth's own oceans. The question isn't what 3I Atlas was. The question is what it was carrying and what it may have left behind. Before we dive in, if you're new here, this channel is your weekly window into the deepest mysteries of the universe. Hit subscribe so you never miss what's coming next. Now, let's get into it. Before we can understand what made 3I Atlas so extraordinary, we need to understand what extraordinary actually means in the context of the galaxy we live in. Our solar system is not unique. There are hundreds of billions of star systems in the Milky Way alone, and every one of them forms the same way. A cloud of gas and dust collapses under gravity, ignites into a star, and the leftover material flattens into a spinning disk from which planets coalesce. But planet formation is violent, chaotic, and messy. Most of the material that never makes it into a planet gets flung outward, ejected on a one-way journey into the darkness between the stars. Every solar system in the galaxy has done this, and for decades, astronomers theorized that the galaxy must therefore be full of these wandering objects, orphaned remnants of distant worlds, drifting in the cold and dark for billions of years, carrying frozen chemical records of the environments where they formed. Then, in 2017, we finally saw one. 1I/Oumuamua was a strange, flat, cigar-shaped object screaming through our solar system at impossible speed, with no tail, no coma, and no satisfying explanation. It left before we could study it properly. In 2019, a second visitor appeared, 2I/Borisov, more clearly a comet, offering a brief but valuable look at chemistry from another star system before it too disappeared into the dark. 2 visitors in all of recorded human history. 2 fleeting glimpses of the wider galaxy. Scientists began to wonder how many of these objects were out there and what they could teach us about how solar systems across the galaxy are built. They didn't have to wait long for a third chance. July 1st, 2025. A routine night at an automated telescope array in Rio Hurtado, Chile. The system, designed to scan the entire sky for objects that might threaten Earth, flagged a faint smudge drifting against the starfield. And within hours, astronomers around the world confirmed what the data was saying. It was moving far too fast to belong to our solar system. It was named 3I Atlas, the third interstellar object ever detected. And unlike its predecessors, this one was coming in bright. Bright enough to be studied, bright enough to chase, bright enough to justify deploying the most powerful telescopes ever built, all at once. Hubble, Webb, Chandra, Maven, the Psyche spacecraft, the Mars orbiters, even NASA's Europa Clipper on its way to Jupiter briefly turned its instruments toward this unexpected visitor. The entire scientific world was watching, and at first glance, what they saw looked almost ordinary. It had a nucleus, a glowing coma of gas and dust, a tail, and it outgassed carbon dioxide and water vapor. Textbook comet behavior. NASA held a press conference in November 2025 and concluded that 3I Atlas behaves like a regular comet. But there were scientists who were not satisfied, because the more carefully they looked, the more stubbornly the data refused to cooperate. The first signal came from the chemistry. Astronomers at the University of Michigan pointed the ALMA radio telescope array directly at 3I Atlas just 6 days after its closest approach to our Sun, measuring deuterium, heavy hydrogen, a hydrogen atom with an extra neutron in its nucleus, forming heavy water that is denser and far rarer than the water we drink. In our solar system, the ratio of heavy water to normal water has a well-established value we know from Earth's oceans, from our comets, from our asteroids. The deuterium to hydrogen ratio in 3I Atlas was more than 10 times higher than anything ever measured in a solar system comet, not slightly elevated, but 10 times higher than the maximum ever recorded across 4.5 billion years of solar system chemistry. And then the second analysis arrived, and it was even more unsettling. The James Webb Space Telescope had been studying the gas plume around 3I Atlas in December 2025, and when researchers processed the data in early 2026, they found that the deuterium enrichment in the comet's methane, an organic, carbon-based gas, was not 10 times above normal, but up to 1,000 times above the cosmic average. The Big Bang itself produced one deuterium atom for every 40,000 hydrogen atoms. Earth, our comets, our ice, all of them have always stayed within a predictable band. 3I Atlas was operating on chemistry from a completely different universe of conditions. The coldest, most ancient regions of the early Milky Way, places so frigid they sit just a few degrees above absolute zero. Scientists now believe 3I Atlas may be between 10 and 12 billion years old, in a galaxy that is only 13.5 billion years old in total. This comet may have been drifting through the darkness for nearly as long as the galaxy has existed. The star it was born around is probably dead, its solar system probably gone, everything it came from erased by time. All that remains is this one frozen messenger and the secrets locked inside it, written in chemistry so extreme that our instruments, pointed at thousands of solar system objects over decades of careful science, have never seen anything remotely like it. The chemical story alone would have made 3I Atlas historically significant, but it was only half of what was troubling serious scientists. Avi Loeb, Harvard astrophysicist, founding director of the Black Hole Initiative, and one of the most provocative voices in modern astronomy, had been documenting something far more difficult to dismiss. What he assembled over 12 months of observation was not a collection of minor quirks, but a systematic case built around geometric probabilities. The first anomaly he flagged was the trajectory. 3I Atlas arrived on a retrograde path, traveling in the opposite direction to everything in our solar system, yet its trajectory was aligned to within 5 degrees of the ecliptic plane, the flat disk where all our planets orbit. The probability of a random interstellar object arriving on that specific geometry purely by chance is 0.2%. Then there was the jet. Every comet in recorded history produces a tail pointing away from the sun, because solar radiation and solar wind push gas and dust outward. 3I Atlas produced a jet pointing directly towards the sun, a tightly collimated stream of material 10 times longer than it was wide, extending hundreds of thousands of kilometers, punching against the solar wind without scattering. No known comet has ever done this. And then Loeb documented that the rotation axis of 3I Atlas was pointed at the sun to within 7 degrees, even at large distances, before the sun could have exerted any meaningful gravitational influence. Multiply those 3 independent probabilities together, and the combined chance of all 3 occurring in a natural, unguided object is approximately 1 in 4 billion. Loeb does not claim this proves 3I Atlas was engineered. What he argues is that science demands these numbers be taken seriously rather than explained away. Before the object finally crossed Jupiter on its way out, Webb delivered one final and deeply strange piece of data: methane. Carbon dioxide and carbon monoxide had been detected in 3I Atlas's plume long before perihelion, as expected, because those molecules sublimate at relatively mild temperatures. Methane is far more volatile and requires much more intense heating to release. It should have appeared early, during the inbound journey when temperatures were rising sharply towards the sun. It didn't. Methane appeared only after perihelion, after closest approach, when the comet was already cooling and moving away. That is physically backwards. Either 3I Atlas had a strange layered internal structure that kept volatile compounds locked beneath at least 10 meters of shielding material through billions of years of cosmic ray bombardment, or something else was responsible for that methane. Because methane is a biomarker. On Earth, approximately 90% of atmospheric methane is produced by living organisms. Loeb raised the question that most of his colleagues refused to touch. What if the unexpected methane outgassing near the Sun was not geological at all? What if something biological, preserved in the deep freeze of interstellar space for billions of years, briefly activated in the warmth of our star? The mainstream scientific response is measured. Exotic chemistry under extreme conditions can produce signatures that mimic biology without requiring it. But the question, once asked, does not quietly disappear. On June 3, 2026, the SETI Institute completed a 7-hour radio scan of 3I Atlas, searching the full range from 1 to 9 gigahertz, and found nothing. No signal, no pattern, no transmission. SETI declared the object natural, and most of the world moved on. But here is what almost nobody is talking about. Even if 3I Atlas is entirely natural, the chemistry it revealed changes something fundamental. If an object formed 12 billion years ago around a star that no longer exists can carry organic molecules, deuterium-enriched water, and complex carbon chemistry across the full span of cosmic time, then the galaxy has been seeding itself with the raw ingredients of life for nearly its entire existence. Loeb has argued that 3I Atlas passed through the habitable zone of our solar system on a trajectory aligned almost perfectly with our planet's orbital plane, and that its sunward jet scattered ice fragments and organic molecules directly into that zone. He calls this panspermia, the idea that life, or its building blocks, can travel between star systems aboard wandering objects, making the galaxy not a collection of isolated biological experiments, but a connected ecology-sharing chemistry across billions of light years. And then he raises the most unsettling possibility. What if it wasn't random? What if an ancient civilization in the early galaxy understood that interstellar objects could carry life across the void and deliberately seeded them? Sent them outward the way a gardener scatters seeds? Not a message directed at us, not a visit, just a quiet and patient act of galactic cultivation repeated across billions of years by something that understood the cosmos the way we are only now beginning to. There is no evidence this happened. But after 3I Atlas, there is also no longer any evidence it couldn't. Here is what we know for certain. 12 billion years ago, in a region of the galaxy colder and older and stranger than anything in our cosmic neighborhood, a comet formed around a star whose name we will never know. That star aged, burned through its fuel, and died. Its solar system scattered, and this one small frozen fragment, no larger than a city, was flung outward into the interstellar dark, where it drifted through the cold between stars, through the births and deaths of 1,000 suns, through 12 billion years of darkness and silence and absolute zero, until July 1st, 2025, when a telescope in Chile pointed at exactly the right patch of sky at exactly the right moment and found it. We had less than a year. We turned every instrument we possessed toward it, decoded its chemistry, mapped its jets, scanned it for signals, and argued fiercely over what it meant. And then it left. What 3I Atlas ultimately was, a relic of ancient planetary chemistry, a carrier of organic molecules from the early galaxy, or something far stranger? We may never know with certainty. But what it told us, simply by existing and passing through, is that the galaxy is ancient, vast, and full of wandering pieces of worlds we will never visit, carrying chemistry we are only beginning to read. Somewhere out there, beyond the reach of every telescope we will ever build, 3I Atlas is continuing its journey, carrying its dark secrets into the darkness between stars, where it will drift for another 12 billion years. Long after our sun burns out, long after our oceans evaporate, long after the last human being looks up at a night sky and wonders whether we are alone, it will still be out there, tumbling through the dark, carrying everything it knows, going nowhere and everywhere all at once. If this story left you with more questions than answers, that is exactly the point. The universe is under no obligation to make sense to us, and 3I Atlas is proof of that. But every now and then, the cosmos sends us something like this, a frozen message from the ancient galaxy, written in chemistry we are only just learning to read. And it reminds us that the story of life in the universe is far older, far stranger, and far more connected than we ever imagined. If you want to keep exploring these questions, hit subscribe. We release new space documentaries every week, and every one of them will change the way you look at the night sky. And before you go, leave a comment with this one question. If you could send a single message aboard an interstellar object for another civilization to find 12 billion years from now, what would it say? We read every comment, and the best answers shape our next video. See you in the next one.